And our next question is going in a little bit of a different direction. You mentioned that general purpose entanglement-based quantum networks are also useful for clustered quantum computing. And how would that work if the quantum, excuse me, I'm getting tongue-tied. How would that work if the quantum network comes from one vendor and the quantum computer comes from a different vendor?
Okay, that's an interesting question. In an ideal world, you would like to be able to connect a quantum computer from one vendor to a quantum computer from another vendor using a quantum network that's produced by yet another third vendor. And personally, I very much believe that this will eventually happen, but it will take time. So at the physical layer, this will require things like standardizing the encoding scheme for qubits. For example, what frequency you use for the photons, what the bandwidth is, what encoding scheme you use, whether it's polarization encoding or time bin encoding. So that all has to be standardized at the physical layer. Then at the control layer, you have to define a whole bunch of control plane protocols, specifically the ones that I just mentioned earlier, the elementary entanglement generation, swapping, purification, etc. And then at the application layer, you have to go further. You have to go beyond networking, because we'll also have to figure out how we can enhance existing quantum computer programming languages and compilers to implement a distributed algorithm that can use the network. We have to invent the quantum equivalent of sockets. Now, in that area, there's actually quite a bit of interesting work that has already started. If you look, for example, at the netCHASM extensions to the QASM programming language, which have been defined by QTech in the Netherlands, you'll see some early direction of work going in that direction. Now, getting to multi-vendor quantum networks is quite ambitious. Right now, we're just trying to build single-vendor quantum networks, but you have to keep in mind that in classical networking, the exact same thing happened. If you go back to the 50s and 60s, all classical networks used to be single-vendor. Digital had DECnet, IBM had SNA, Apple had AppleTalk. Pretty much every computer vendor in those days had its own proprietary networking protocol. And these days, because of the need for interoperability, everything has been standardized. And the TCP/IP stack makes multi-vendor networking completely routine these days. So I have no doubt that a similar thing will happen for quantum networking. And in fact, this is one of the things that we're working on, but it will take some time before we get to multi-vendor quantum computing, clustered quantum computers.